Okay, let's look at this problem here. So I just changed this. There's a typo in this. While I was making my video, I just changed this. It was way too big. This should be this. As the product, and then in the worksheet it's correct, and you'll notice there were some reagents missing, and there were steps missing, and anyway, I fixed it on the worksheet, and I fixed it with just kind of drawing it in on my iPad just to avoid a couple of extra steps here. But yeah, let's take a look at this. So this problem is probably the hardest. These are going to be the hardest ones on the quizzes. And, but there shouldn't be any mistakes on the quiz. I think the practice problems just didn't get edited particularly well. By whoever our TAs and stuff are working on this, and we're all kind of, everybody is kind of doing the best they can right now. So try to be patient with them. Be patient with me. We're just gonna try and get through this thing together. All right. So anyway, so let's take a look at this. Yeah, so the only thing that's different about this problem, so, in the videos and stuff, the way we usually work problems is we say, whatever carbons are in the starting material have to be in the product, and you can't get carbons from anywhere else. And part of the reason for that is because, we don't want you just inventing reagents, but here, since we're giving you a reagent bank, you'll notice that some of the reagents, really one of the reagents, has carbons in it. And so just be wary, look out for that. Okay, so you don't want to get into if you've been following along the videos and stuff, you don't want to think, okay, I've got extra carbons here, I've got 1, 2, 3, 4, 5, 6 in the product. That does imply that you have to form a carbon-carbon bond, so that part is correct, but the carbon-carbon bond reaction doesn't have to join two starting material molecules. If you're given other starting materials, you're welcome to use those. So this problem is different just in that regard. The only other reagent that has carbon in it is cyanide, but that's not particularly useful for us. And so yes, I'm just drawing your attention to that. Okay, so yeah, but otherwise we're just going to kind of work it like a normal problem. So we know we're forming a carbon-carbon bond. Okay, so that's one clue, is I'm forming a carbon-carbon bond. That's really our main clue. There's an aldehyde in the product. We're going to return back to that. But the first thing you usually want to do is just form the carbon-carbon bond. So for carbon-carbon bond, we know that comes from the acetylide anion, which remember is just this deprotonated alkyne thing. And it comes from an alkyl halide, or haloalkene, or whatever you want to call it. But it comes from a primary alkyl halide, and that's going to be something that looks like this. And so we're gonna think in the same way that we have previously, and that we want to, ultimately we're going to be connecting two things like that. And so you could work your way backwards here, and that's not a completely crazy thing to do or anything from this. But since this is a multiple choice, you would cut there, and then you'd have to make a choice about where the alkyl halide went. And it would go there because we know that this is one of our reagents, and that's one way to look at this. But since this is multiple choice, we can look at it in a different way. Since we know we're going to need this and we know we're going to need this, really what we're trying to do is just kind of push towards both of those. The obvious thing here to me is that since we've got 6 carbons in the product and we've got this 2-carbon reagent down here, is that we're probably going to take this 2-carbon reagent, which is itself an acetylide anion already, and we're going to have to link it up with an alkyl halide. And so, we're usually this is something you take and you make it out of the substrate. Here we're kind of using it like it's a reagent because it's in your reagent bank or your answer bank here. So that's kind of the only weird thing about this question. Otherwise, it's pretty standard. Otherwise, it's a pretty standard synthesis type thing that we've done. So usually what we're doing, we know we have to make a carbon-carbon bond, is we're pushing towards, we're going to use the two recipes that I taught you in your lecture videos, we're going to push towards making an alkyne or acetylide anion or whatever, and we're going to push towards a primary alkyl halide. Now, since we're given the acetylide anion here, so some of the work is already done for us. We don't have to make this, it's just kind of given to us. But we do still have to make the alkyl halide. And so you can kind of consider what the alkyl halide would look like if you want to do some retrosynthesis here. Well, oh yeah, right, I forgot I corrected that. You can kind of consider what the alkyl halide would look like if you want to do some retrosynthesis here, which is what I kind of started to do at the beginning. But so one thing you could do is say, okay, well, if I'm breaking this thing up, what is it going to look like? And kind of muck this thing up really bad over here. But let me actually, maybe I can use white. So we're joining this carbon here to, maybe we can use this. That's not what I wanted to do. To this carbon here. That doesn't show up particularly well, but let me pick a different color. How about red? There we go. Yeah, so we're joining those two carbons together. I'll use blue over here. There we go. Okay, so so when we join those two things together, we know that we end up with and this is a little bit redundant if you've watched all our videos. Yeah, so we're going to be forming that bond there. So, when you come back over here and you're trying to do that analysis on this substrate, this one you got to be careful on. So a lot of the ones I've worked in the homework, remember, they're like pretty symmetric, so it doesn't really matter which side you choose, the alkyne or the alkyl halide or whatever, but this one it does. And which side do you want to end up being the alkyl halide, and which side do you want to end up being the alkyne? Looks like I've chosen poorly here. Let me fix that. So if we're indicating the alkyne side with blue, then naturally we want that to be this 2-carbon side, because we know that our reagent up here has 2 carbons in it. And then if we're indicating the alkyl halide with red, we know that we want that to be on the other side. So, what are we working back to here? We'd be working back to, so we break it right there, and we cap both ends with something's wrong here. 1, 2, 3, 4, 5, 6. It's okay. Oh, I see. I put this in the wrong spot. Sorry, y'all. So that should be in red. I counted the oxygen as a carbon, and that should be in blue. So we're breaking the bond right here at carbon 4, 5. That would be the equivalent of, if we called that 4, 5 over here. And I just messed up with how I was counting the carbons there. Okay. All right, but yeah, so we were going to push towards, though, is this. And then, what is this thing going to end up looking like? Yeah, okay, so, is it a bad idea to do some sort of retrosynthesis? Eventually, we're going to have to figure out a way to incorporate this into the final molecule. But we know that at some point, if we formed a carbon-carbon bond, it's going to look like that. And if we actually go through the full retrosynthesis here, if we have an aldehyde on the edge of the molecule, how do we make that? We make that from an alkyne. You know a couple of ways to do that. One is with ozonolysis. There's no way to do an ozonolysis thing here that there's no way to do ozonolysis here in the number of steps that you're kind of limited to. So you started with an alkyne here. Again, because I'm tired, I'm going to check this really carefully. Checks out. So just if this part, I don't know that if I've gone over this exact thing in a video either. I'm going over it in this video. But remember that if you want to make an aldehyde, you'd want to, what you should be queuing up in your head is like, what are all the different ways to make an aldehyde? So that's like a little node. And yeah, oops. And yeah, so how do we do aldehydes? We know a couple of ways to make those, right? One is we can use ozonylysis, so we can start with an alkene and use ozone and dimethyl sulfide. Actually, we know a few ways now, don't we? Another way to do that would be to start with an alkyne and add in, we could do hydroboration, actually. Remember we use our special reagent for this, hydroboration, and then we want to do oxidation afterwards. And the third way, the third route, is to actually take an alcohol, and we can use pyridinium chlorochromate to make that. So we've got a lot of different ways actually to make an aldehyde. But the obvious direct route that we could use here, since we know we're going to have to use an alkyne in our synthesis, is to use the alkyne directly. And so, even though we have a few different ways here, ozonolysis makes the least sense. The alcohol, we probably could figure out something, but again, I don't think you can do that in the number of steps we have. This makes the most sense, right? If you can just take the alkyne directly to an aldehyde, that's your best case scenario. And that's what we're going to end up doing up here. So that's one way to get about this, is to do this sort of retrosynthetic analysis type thing. But, with multiple choice, and just kind of like trying to work these problems the best you can, it's not like you always have to go that route. I know that can be a little bit challenging when you're first getting going. Nobody wants this R to come for a ride. There we go. So, maybe that's not your preferred method of working things. But you can probably push forward just from let me cut this as well and shrink it down. You can probably push forward just from what you're started with and just try and push in one direction. So, there's a bunch of different ways to do this. And so one thing you could just think about is well, I'm forming carbon-carbon bond. I know I'm going to have to form an acetylide anion or an alkyne, and I know I'm going to have to form an alkyl halide. And if you recognize that the acetylide anion you have is just kind of given, and it's 2 carbons, then it immediately tells you that this thing over here, this substrate over here, is going to have to be your alkyl halide. And you know that your alkyl halide has to be a primary alkyl halide because it's the only way this reaction works. So you could just start by saying, I have no idea what the hell I'm doing. Hopefully you at least identified the carbon-carbon bond part and got this far. But if you don't know what you're doing, you're starting with an alkane, the first step is always to do radical halogenation. So a lot of students get stuck here, and I really tried to make a point of this in the synthesis videos that I worked on for you guys. This is not a primary alkyl halide. Okay, if I try and first of all, if I try and react that, even if I could get it to react in an SN2 style reaction with the acetylide anion or whatever up here, I wouldn't get the product I want anyway. But it doesn't even undergo that reaction, right? This would just go through elimination. So don't get stuck there. If you're trying to push towards the alkyl halide that you need for to react with an alkyne, you have to push towards a primary. So from here, you would use some sort of strong base. So I'd go up here and I'd look through, all of these things, and I'd look for a strong base. And what I see is right here at 6, I have sodium amide. So I can use that. And that gives me this. Okay, now I can transform that into, let's see, actually let me go and double check my reagents just to make sure it's there. But okay, right, I went and added this one by hand. But yeah, so HBr and peroxides will work for that last step. And that gives me the primary alkyl halide. And then I know that I can take a primary alkyl halide and I can combine it with an alkyne, or acetylide anion in this case. And that will, in fact, give me something very close to my product. Let's see, so now I've replaced that carbon. Yeah, so now I'm just adding on carbon 4 now, connects into carbon 5, which connects into carbon 6. Okay. Yeah, be really careful when you're forming those bonds, because I like to feel like I know what I'm doing, but I'm pretty tired and I'm almost making mistakes. Okay, so anyway, so that gets you really close. And then in the final step, so this would be step A, step B, step C, step D. And so you can kind of push in that direction, even if you can't quite get the retrosynthesis figured out. And then it's like, okay, well, I formed the carbon-carbon bond. I knew I was going to have to do that. And you took up 4 steps. There's one more step. What could it be? And this, I feel like students have a tendency to just forget this reaction, and I don't know why. I guess it's sort of a weird reaction because you form an enol and then it does a tautomerization. But yeah, if I've got an alkyne, there's a handful of things I can make with it. And one of the more useful things I can make with it is probably an aldehyde or a ketone. And the way I can do that is I can take one of the bulked up borohydride reagents. In this case, I think we use sec isoamyl borohydride. And then I take that and I can do a hydroboration oxidation. So be careful. The only thing I guess I'd say, okay, so the TAs have either been generous or they just made a mistake. Either way, it's a generous thing because it's not correct no matter what. You don't want to use BH3 here. You have to use if you're trying to make an aldehyde on a terminal alkyne, you have to use this sec isoamyl, or there's some other reagents that you can use, but usually this is the one we reach for to do that. Let's see. Yeah, so when you do that, remember that you form the enol, and it's the enol where it forms sort of anti-Markovnikov. So it forms at the less substituted carbon. But then that's not really stable. You don't even have to draw that out. It doesn't count as a step. I just draw it because it helps me know where to put the aldehyde. What you actually end up with is this, which is your product. So that would be thing E. The only thing I was pointing out up here is that BH3 in peroxide, the peroxide should be in the second step here. I think that's just a typo. But no matter what, you don't want to use that reagent. Okay. So yeah, so then you'd want to come in and I guess in Canvas, at the bottom where you're putting in your answer, there'd be A, B, C, D, and E, and you just want to go in and fill all your reagents in. And so I want to come back up and find them. So I'll just go in order of color here. So reagent A is Br2 in light, and so down here I want to make sure I put in the number that corresponds to that, and that's number 13. And then let's see, what are we going to put in for B here? So B is the sodium amide. So I want to find that. That's going to be 6. So I'm going to go and put that down here. This reagent here. And then when I go to C here, I'm trying to find HBr and peroxide. So I've written it out as hydrogen peroxide, but obviously this also counts as peroxide. So that's going to be number 16 that I enter in. And then D is the acetylide anion, which is this, which we know where that is. It's the first thing we noticed in there. And that's going to be answer 5. And then problem E, finally E, that's just going to be this borohydride reagent. And we come back and check that out. And we put that in. So that's going to be 9. And so that would be your answer list for that. And that's how we do multi-step synthesis. When we're trying to do multiple choice, you kind of choose it from a reagent bank. So yeah, so naturally this problem is pretty challenging. So make sure you have like I don't know, I would make a crib sheet, I guess, if I was in your position. I would make a crib sheet showing me how to make alkynes. And I said this in a video, I'm just going to say it again, in one of the lecture videos, but I'm just going to say it again. Before you go into the quiz, I would recommend doing, let me get the scissors out here, this thing here, this little piece, minus minus the piece that came with it. Okay. This little piece here. This is like, you know, I think in terms of like what you're trying to figure out, and this one's a little bit messy because I have colors everywhere. Let me simplify that a little bit. This is really important. So be sure that you kind of can be able to do this. You want to be able to go kind of in both directions. I want to be able to say, you know, if I break this up, you definitely want to be able to say, try to get close to the color palette I started with here. You definitely want to be able to kind of indicate where you're breaking this thing at. I want to be able to say, okay, that part, when I go backwards, one side, the blue side, becomes the anion. That's that carbon there, so it's an actual carbon atom. You'll be able to identify that. And then the other side becomes a halide. So I feel like most people get, like when you look at ozonolysis, people are like, oh, I just erase the double bind and replace it with oxygen. So you sort of cap it. This is sort of similar to that, right? Like I'm cutting this bond in half when I go backwards in time the way I think about it. But instead of capping it with oxygens, I'm sort of capping it with an anion or an alkyl halide. So it's a little bit harder, but it's the same kind of rationale. But yeah, you definitely want to be able to kind of do that. So you can use numbering, you can do all sorts of stuff, but just like really kind of be able to understand how to go back and forth between those and make sure that that makes really good sense to you. Because no doubt there's a carbon-carbon bond forming reaction on the quiz that you're going to take, and it's going to involve this strategy. And so yeah, so also probably important is to know all the different things that an alkyne can form. So, you know, an alkyne can form alkynes can form, I'll just use the terminal alkyne, but alkynes can form aldehydes, they can form ketones, depending on the reagents, right? I can do double bonds there. And so, you know, if you see that in the target molecule, like if you see one of these functional groups in the target molecule, then you have to be able to kind of know what the reagents are that allow you to go back. And really, I could draw these arrows going in the other direction. Well, no, that's right. You need to know what reagents allow you to do that. So, you know, here you're going to be using the hydroboration reagent that we just looked at. Here you'll be using you know, mercury with sulfuric acid or whatever to make the ketone, and then like here you would use like H2 and Lindlar or sodium and ammonia or something. But you need to know how to do that because like just like in this problem that we just looked at, your target molecule here, like you might be able to put together that, okay, I got to form a carbon-carbon bond, but you also need to be able to say, okay, I got to form a carbon-carbon bond. I know there's an alkyne in there. You know, is it possible that I could have made whatever functional group is actually in there from the alkyne? And I think I worked some problems like that in the workbook. But you want to be able to think backwards in time. That's the one way to do it. That allows you to get to pick up a carbon atom there, didn't I? That allows you to go back and say, okay, I know that I can make this. I know I can make it from this, right? I know the reaction that takes me in that direction is the hydroboration oxidation reaction. You know, just the same in the same vein of things. If your product would have been like an alkene or something, and not an aldehyde, you would again want to think like, can I make an alkene from an alkyne? That's sort of the thought process there. So these are tricky, but you know, this isn't the entire test. I think we have like one or at least maybe two questions on there that are like this, and then the rest are a little bit more straightforward. So. But yeah, give this a lot of practice. Look at the videos, look at the workbook problems. I think I worked all the workbook problems for the alcohol chapter in there. And just really, 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 really spend some time looking at this reaction of taking acetylide and reacting with an alkyl halide, and trying to internalize that in whatever way you can. Okay, good luck with your quiz, guys. I hope it goes well for everybody. And if it's not going well, you know, I am always open to you guys sharing your frustrations with me over emails, and I try to get back to everyone. I at least read every single email. So just let me know, and you know, we'll straighten things out. So, all right. Thanks, everybody.